Hello everyone, this is Austin Harris and we're back again. Today we're going to go over short PowerPoint slides over removal of a node from a binary search tree. So let's get started. So first off, we just want to talk real quick. I like to use things that help us kind of visualize, kind of like we do in class with the cups. I think it's a great way to learn, so we will be doing that. But first off, let's talk quickly about the remove operation. The remove operation is one part of the total algorithm. So the remove operation is more complex than the add or search operations. And the remove operation can be divided into two stages. The first one is search for the node that you're going to be removing, and then if the node's found, then you run the remove algorithm. So we're going to walk through the removal of a node from a binary search tree. But real quick, before we do that, let's talk about the situations. So we have three different possible situations when removing a node. First off, the node that we're removing could have no children, or the node that we're removing could have one child, or could have two children. So we're going to look at all three of those cases. So step one for no child. So we have the 5, 2, 18, -4, and 3. -4 is what we want to remove. So as you see, it does have no, it has no children, like we talked about. So this is step 2, and this is all the steps. So what happens? So in this case, the algorithm sets the corresponding link right here of the parent null and disposes of the node. So basically this node, it disposes of this link to its parent node and just gets rid of the node that we plan on getting rid of. Now, looking next one is if they have one child. I will correct this before I submit these PowerPoints. It should say one child. So step 1. So we want to remove the 18. The 18 has one child itself. So in this case, the node is cut from the tree, and the algorithm links the single child with its subtree directly to the parent of the removed node. So let's take a look. So one more. So we cut those links out, and now the link is formed. That's the green line is formed directly to the parent of the node being removed. So, so the green line represents that new link. And then I am sorry. Let's see here. All right, we were right here. So once that's done, this is what the final tree will look like once we have removed that node. As you can see, 21 now just has one link to the parent 5. So now our last situation, there are more steps to this one, and this is what happens when there are two children. So as you can see, 12, it will be red, is the node we want to remove. It has it does have two children, 9 and 21. So before I go farther into that, I want to talk about a property of binary search trees. So this property is basically a way to transform binary search trees. So let's say you had 5 as the root node, and to the right you had 21, which had two separate children, 19 and 25. We could transform that into where 19 is the root node and 5 is on the left and 21 and 25 are on the right. What happened, the way we do this, so to transform a tree, we choose the minimum element from the right subtree, and we replace the root by that minimum element, and then we hang the original element to the left. So that's going to come out come in handy for this when we're removing a node which has two children. So the kind of our goal is to find the minimum value in the right subtree. So we look at 12, and that's what we want to remove. Now we found the minimum value, which is 19, in the right subtree of the node we're removing. Next, we replace the value of the node to be removed with the new found minimum. So it will have a duplicate now. So we're going to take that 12 and put a 19 there. It's just like this. So after that, apply the remove to the right subtree to remove the duplicate. So now we are able to remove 19 as we did in situation 1, where we're removing a node with no children. So we just remove the link and discard the node. So there we go, and that's all we have. So next, I wanted to add the remove part of the binary search tree. I just wanted to have some code in these PowerPoints in case anyone ever needed it. It's here. That way, instead of just having kind of the visual understanding, this will help with some of the code side as well. I hope that helped everyone out, and I hope y'all have a great day. Thank you.